Interpreting simulation results. 59. Go to cell G284, which contains the forecast price for the portfolio at the end of the 24-month period. 60. Click on Browse Results. The following histogram curve will be shown. 61. Write 200,000 and 300,000 on top of the two vertical delimiters. This will shift both delimiters to those respective portfolio values as follows. The expected value of this investment after 24 months is $233,678. This is an annualized return of 7.36%, as shown on cell N284. The range of possible outcomes is very wide, with a minimum of approximately $112,000 to a maximum of approximately $622,000. The probability of a value smaller than $200,000 after 24 months, that is, a loss of value, is 25.9%. The likelihood of increasing your worth by at least an additional $100,000 is 9%. In approximately 2 out of 3 possible outcomes, the final value of this portfolio will be between $200,000 to $300,000. This information, being read directly out of the chart, is also available in the statistic functions that we created on top of the ranges, I284:N284. There are other ways in which the dynamic profile of your portfolio can be seen along the time span. For example, imagine that you are interested in viewing the potential value of your portfolio every 6 months, that is, on month 6, 12, 18 and 24. You could overlay respective charts as follows. 62. Click to the summary icon on @Risks ribbon. 63. Scroll down to June 2019's row and drag the thumbnail chart out of this window, creating the following chart. 64. Next, go back to the results summary window, scroll down to December 2019, and select the respective thumbnail chart. Drag it on top of the previously created chart to overlay it. 65. Do the same operation 2 additional times to overlay charts for June 2020 and finally for December 2020. By the end of this process, the overlaid charts should look like this. For presentation purposes, however, we still need to modify several details in this chart in order to make it more readable. 66. Stretch the whole chart in order to expand it to cover the whole screen. This will allow a clearer picture of its details. 67. Drag the right-hand side wall of the statistics border towards the left, in order to be able to show the 4 existing statistics columns. 68. Place your cursor on top of the probabilistic bar, which at this point, by default, only shows 2 probability bars at once. Right-click on it. You will see several context-related options. In this case, select the first alternative delimiter options. @Risk will now open the Graph Options window directly on the tab that deals with delimiters. 69. Change the 2 for a 4 on the number of delimited curve setting and click OK. At this point, the chart will show probability bars for each one of the 4 time periods evaluated. 70. Make sure the vertical delimiters are respectively placed at 200,000 and 300,000. The finished chart should now look like this. Now you can read, for example, the change in probability of losing value along time, shifting from 42% after the first 6 months, to 35% after a year, and finally to end at 25% after the 2-year period. Note that you can always manually drag the vertical delimiters to any other point on the curve and observe how the probabilities change dynamically as well. Also, observe that the statistics table changes respectively when shifting these 2 vertical delimiters. At this point the model is ready to be optimized, in order to comply with several investment objectives that could be recommended to the investor's taste. We have been using an arbitrarily assigned equivalent basis of investing 79 ounces for each one of the 4 metals. This roughly equates $200,000 as a starting point. We will now use RiskOptimizer, the stochastic optimization tool that @Risk has, in order to build the best portfolios that comply with certain investment objectives. Simply put, the portfolio is no more than the quantity placed in ounces for each one of the 4 different precious metals.